Hi everyone, welcome back to the channel. Today we are building a super cool AI-powered QA app using Python, Streamlit and DeepSeek. In the previous video, we built a basic RAG using DeepSeek, where user can upload PDF and ask questions based on the PDF. In today's tutorial, we are building a chatbot where user can add a topic. Based on the given topic, chatbot will fetch the content from the Wikipedia and feed that content to the DeepSeek model. Using this updated content, model can answer user's question. I will show the demo first. As you can see, the chatbot fetches the content from the Wikipedia and feeds it to the LLM. And we can get answers based on this content. Now let's look how we can build this system. This is the basic architecture of this system. Here, using the Streamlit UI, user can input a topic. Using the Python Wikipedia API, fetch the corresponding content from Wikipedia and feed that content to text splitter and save the text chunks in FAISS vector database. DeepSeek LLM will use this content to answer users' question. Now we can set up this chatbot. First of all, we need to install Ollama. Go to the official website of Ollama, download and install the platform in your local machine. Then pull DeepSeek model. Here I am using DeepSeek 1.5b. You can use another models if you want. Run this command to pull the model. The LLM is now running in your local machine. Next step is to install the required Python libraries. Run this command to install all the required libraries. Streamlit for building the UI, Wikipedia API for fetching the Wikipedia content, Ollama for running DeepSeek, FAISS and LangChain for vector search. Once you install the libraries, let's create a Python file to build this system. I had already written the code. I am not going to explain the code line by line, rather I will explain the major functions. I will share the code in the description box. You can check and do the changes that you want. Let's check the major functions. This checks if index exists in session state. If it doesn't exist, we create it and set it to none. This ensures that session state index always exists when the app runs. Index stores the FAISS database for fast search. Documents stores the text chunks for retrieval. Embedder converts text into vector representation. This ensures our data stays available even after user interaction. The get Wikipedia content function retrieves Wikipedia content for a given topic using the Wikipedia API. It initializes a Wikipedia API instance with a specific language, which is English in default, and a user agent for identification. The function then searches for the topic and checks if the page exists. If found, it returns the page text. Otherwise, it returns none. This allows fetching Wikipedia articles programmatically for further processing. For example, if you pass a string like operating system, it returns the corresponding article content from the internet, which can be analyzed or summarized in later stage. This function, create vector store, converts text chunks into searchable FAISS vector database. It assesses session.embedder, which is a preloaded sentence transformer model. This model converts text into numerical representation called embedding. Embedder.encode transforms the input chunks into a high-dimensional vector representation. The function determines the embedding dimensions using embeddings.shape. It creates a FAISS flat L2 index for efficient similarity search. The function adds embeddings into the FAISS index. It returns the FAISS index and the original text chunks, enabling retrieval of relevant text based on the query similarity. This is essential for Retrieval-Augmented Generation, allowing AI models to fetch contextually relevant text efficiently. The retrieve context function finds the most relevant text chunks for a given query using FAISS. It first encodes the query into an embedding using the stored embedder model. Then it checks if the FAISS index exists. If not, it returns none. If the index is available, it searches for the top k most similar embedding by computing distance between the query embedding and stored document embedding. The function retrieves the indices of the closest matches and returns the corresponding text chunks from session state.documents. This helps provide relevant context for answering queries in a RAG system. Generate answer with Ollama. This function is responsible for generating an answer using the DeepSeek model via Ollama. The function takes two inputs, query and context. Query is the question that the user asks. Context is the relevant information retrieved from FAISS database. It joins the list of context chunks into a single formatted string using the /n to make it easier for the model to read. The function creates a prompt that instructs the AI to act as an expert assistant. The context is provided, so the AI can answer based only on that information. The question is added at the end, guiding the model to generate a relevant response. The function sends the prompt to the DeepSeek model using the Ollama.generate function. The temperature is set to 0.3, meaning the model's response will be more focused rather than too random. The max tokens is set to 1000, ensuring that the model does not generate overly long response. Finally, the function returns the generated response from the DeepSeek model so that it can be displayed in the application. The function takes a user query, retrieves relevant context, constructs a detailed prompt, and sends it to the DeepSeek model to generate an answer. It ensures that the responses are based only on the provided context, making it useful for RAG-based QA system. Now let's run this application using this command. It is running in localhost 8501. As you can see, we can give different topics and ask questions based on the topic. The performance and latency depends on your hardware which you running the model. I will share the code in the description box. You can check it out. I had uploaded two different scripts, one with RAG and another without RAG, where content is directly passed to the LLM. Check those scripts and try it out. So that's all about today's video. If you found this helpful, please consider to subscribe and like the video. Thank you for watching and see you in the next video. Bye.